back. Today we're talking about adding integers, and they're going to have the same sign, different sign, or they're going to be straight opposites. I've got a chart here for you, and in this column over here, this is going to be my examples column. And so we're just going to put some examples in there. For example, if we've got integers with the same sign, so I'm going to put 2 in here, and so what we're going to have is like a 5 plus 3, and that's going to equal 8. Notice, I'm going to add the absolute values and keep the common sign. Okay, so it seems silly because we know, oh, 5 plus 3, that's 8. But we can see that, but it's really the absolute value of 5, which is 5, plus the absolute value of 3, which is 3, and it's 8, and they're both positive, so our sum is positive. Same thing happens when we have like a negative 4 plus negative 11 per se. And what we're going to do is the absolute value of negative 4 plus the absolute value of negative 11, which is going to give us 4 plus 11, which gives us 15. But we know that we're adding some negative, so we're at negative 4, and we add negative 11, meaning it drops 11. So we're going to have a negative 15. So we kept the common sign. See how we kept that common sign of negative and negative? So that's integers with the same sign. But what about when they have different signs? When they have different signs, it's like, which one's bigger? Am I going to end up positive? Am I going to end up negative? Where do I end up? And so the simple way to remember this is we're going to subtract the lesser of the absolute values from the greater, keep the sign of the integer with the larger absolute value. That sounds like a lot of math stuff, but let's look at an example. An example of this would be negative 15 plus 8. Okay, we could model this sum with counters and have negative 15, so 15 red ones and then 15 yellow ones, or 8 yellow ones, and we know we'd end up with more red, so we know our answer is going to be negative, or we could start on a number line at negative 15 and walk back 8. But what I'm going to suggest to you is this. Let's take the absolute value of 15 and subtract the absolute value of 8. And what that's going to give us is 15 minus 8, which is 7. Okay? So my number component is my numeral component is going to be 7. And since 15, it has the larger absolute value, my answer is going to be negative. Think about that. I'd have 15 red counters, those negative counters, and I'd have 8 yellow ones. Well, I'd end up obviously with more red, so I'm going to subtract the larger of the absolute value, subtract the lesser from the larger, keep the sign of the larger. Let's talk about opposites for a second. Opposites look like this, negative 4 plus 4. Well, different sign, so what we're going to do is the absolute value of negative 4 minus the absolute value of 4. So I have 4 minus 4 equals 0. Anytime you add opposites, they're going to end up with 0. They're called the additive inverse. It undoes it. So the additive inverse would be the opposite of a number. Let's look at a couple of examples. Here I've got negative 11 plus 6. Okay, so when we are adding, we have to evaluate the same sign. Well, I don't have the same sign, so I'd have 11 red counters and 6 yellow ones. So I'm going to follow the different signs rule here. So what I'm going to do is I'm going to take the absolute value of negative 11, and that's 11, and the absolute value of 6, which is 6. I'm going to subtract those. Lesser from greater, and I'm going to end up with 5. And then I need to look up and see, well, which one had the greater absolute value? 11 has the bigger absolute value, so I'm going to keep the sign of that number. So my answer is negative 5. All right, different signs, subtract them, keep the sign of the larger absolute value.